We're at gotomath.com and working some calculus. We're down here at the first derivative test, and I need to check this out real quick. I believe we just got through doing that one, so we are now doing 14-1, it looks like. I had to look that up. Oh look, we got a graph finally. Find where the function is increasing and decreasing. So this is the graph of f of x, and we're just going to kind of look at this. So you can see the graph is decreasing up to, it looks like the vertical asymptote is at 2, and then the graph is decreasing from 2 to infinity. But we'll want to prove that mathematically, right? So I guess what we need to do is actually write that down. 4 over x minus 2 plus 7. I think I can remember that. 4 over x minus 2 plus 7, and I did forget what the name of the function is. It's f of x. I should have known. F of x. Alright, so the first thing we're going to do is obviously take the derivative. So f prime of x is equal to, and actually, you know what, let's rewrite this. We could use the quotient rule, but when we just have a constant in the numerator, it's a whole lot easier for us to take the derivative when it's in this form here, okay? So take this 1, negative 1, bring it out front, that gives us negative 4. X minus 2, subtract 1, we're at negative 2, and the derivative of a constant is 0. Of course, remember we got to take the derivative of the inside and bring it out, but it's just 1. Alright, so now what I'm going to do, kind of skip a step, we're going to set this equal to 0. I'm going to go ahead and bring this down into the denominator, and of course I've already forgotten to put a c in for x, but that's okay. Anyway, alright, so this is where we're at. Now, here's the question. What could I plug in the numerator to get 0 up there? And obviously nothing. What about the denominator? So it looks like we have a critical number at 2. Now remember that this critical number must be in the domain of the original function. And is it? No. Uh-oh. We got some issues going on here because 2 is not in the domain of the original function. So technically that's not really a critical number. But what we're going to do is, and I'm not sure I've talked about this or not, but we are going to use 2 anyway. Okay? So this is not a critical number. You got to understand, remember what critical numbers are. Alright? But we're going to use this vertical asymptote to actually determine the increasing or decreasing on this. Now we can use 0. 0 is actually in the domain here, and we can use 3 as another one of our test points, and we're going to actually do that. So we want to take 0 and plug it into the derivative here, and of course what we end up, this is squared, so we're always going to get a positive number, right, in the denominator, and then we have a minus out here, so this can always be a negative. Then that's going to be a negative, so we know that the function is decreasing. Okay. And then we plug 3 in, same thing, it doesn't matter, it's negative also, and therefore the graph is decreasing. Okay. Okay, so kind of the switch here is being careful here about the critical number, because we got the situation we have decreasing and decreasing going on here, right? So we do use the vertical asymptotes to determine that. Okay, and of course we can tell by kind of looking at the graph what's going on here. But let's click the answer and make sure everything's okay with that. And we get decreasing from negative infinity to 2 union 2 to infinity. Alright, so that's the reason I threw these in there. A little different from what we've been doing. So we're gotomath.com. Come on by, practice that, and I'll see you later.